Hello everyone, I hope this webinar finds you well. I see some people are in the process of joining us. Let's give them a little more time. Welcome to Frontline Systems webinar on Analytic Solver Data Science. My name is Dr. Sima Maliki, and it brings me great pleasure to serve as your host. Thank you for joining us. Our plan is to cover a wide range of topics. Due to our time limit, I encourage you to send any questions you may have to consulting@solver.com. This will ensure we can address them thoroughly. Today, we explore Analytic Solver Data Science and its predictive analytics capabilities within Excel. We begin by conducting analysis and feature selection to assess risk factors relating to a medical condition in a healthcare application. Following this, we identify the most suitable machine learning algorithm that fits the data. Once the model is trained and validated, we transition into utilizing it for predicting health outcomes on a new data record using a score option. Next, I will illustrate the creation of a multi-step data science workflow in Excel that facilitates the integration and comparison of various data science techniques. We then take our workflow to the cloud where we create a user-friendly web application. We wrap up the webinar with synthetic data generation and crucial assessment of risk of a machine learning model before it is put into production use, helping you avoid potential pitfalls. We will quantify performance disparities between the machine learning model's behavior on simulated data versus its performance on training, validation, and test datasets. Analytic Solver is an all-in-one solution that works in Excel. Excel is a powerful tool and easy to start with. Yet to make faster and more accurate decisions, you need to empower yourself with decision intelligence. You need to take the next steps and go beyond Excel and share your resulting insights in a repeatable and manageable process by creating a custom web application or a mobile application, for example. The good news is that Analytic Solver allows you to go beyond Excel with point-and-click deployment of your models. Furthermore, Frontline offers other exceptional platforms such as Excel Miner SDK and Raisin Decision services that equip you with other advanced capabilities. If you want to use programming languages such as C, C++, C#, Java, R, Python, or more, you can use Excel Miner SDK platform. If you're interested to have a web or mobile application, you can use our Raisin Decision Services platform and REST API. The beauty is that all platforms are fully compatible with Analytic Solver in Excel, and your efforts in creating a proof of concept or a model in Excel are well invested. Now that you are more familiar with an overall picture of our product line, let's open Analytic Solver for a quick overview of the data science ribbon. Get data allows you to draw a random sample of data or summarize data from various sources. You can work with another Excel worksheet, different databases, such as SQL Server, Oracle, Power Pivot, or a data set with up to billions of rows stored across many hard disks in an external big data compute cluster running Apache Spark using big data options. Generate data function creates synthetic data when there isn't enough original data. The Explore tool allows you to visualize your data and provides you with feature selection and analyze data capabilities. We will practice them today. Next is Transform. This tool offers a complete set of data handling utilities to clean your data. This includes missing data handling, transforming continuous data and categorical data, and principal components analysis. Clustering or data segmentation aims to group or segment a collection of objects, also called observations, individuals, cases, or data rows, into subsets or clusters. We offer two clustering methods, hierarchical and k-means clustering. Then we have text mining tool, allowing you to gain insights from your unstructured text data. Here are built-in time series analysis tools, including partitioning, ARIMA, and smoothing techniques. In data science group, you have access to partitioning, including standard partition and partition with oversampling. This is where you can partition your data to training, validation, or test sets. Imagine you have a data mining project and your goal is to predict an outcome based on a set of features. You can use supervised learning algorithms. Supervised learning includes classification and prediction methods. Here you have access to 10 supervised learning algorithms, including 6 classification from discriminant analysis, logistic regression to neural networks, and 4 prediction methods. Predict enables you to identify a value for a continuous outcome. For example, if you want to predict a fair market value of a house or how many units of your product the customer will purchase in the future. You can use classify when you are predicting a discrete categorical outcome. For example, when you want to find out if an online transaction is fraudulent or not, or if an insurance applicant is a high, medium, or low risk. You can build better classification and prediction models using ensemble methods available for both classification and prediction algorithms. Furthermore, Analytic Solver offers augmented machine learning features. If you use find best model in classification or prediction algorithms, Analytic Solver will automatically test and fit parameters for multiple types of machine learning models. It validates and compares them accordingly to your chosen criteria and delivers the model that best fits your data. Furthermore, risk analysis of machine learning model is available on the fly within each of data mining algorithms. It is through a tab named simulation. Then you have association rules, score option, you can check your license status, and AI agent. Analytic Solver offers an AI technical support agent based on the same technology as ChatGPT that had studied thousands of pages of frontlines, help, and user guides. Everything about optimization, Monte Carlo simulation, and data science is available for you to utilize. Let's focus on a health scale application and explore a few of these features. Click on Help, Example Models, Forecasting Data Mining Examples, and let's open Heart Failure Clinical Records. Cardiovascular disease, such as myocardial infarction and heart failure, claim approximately 17 million lives annually worldwide. Heart failure arises when the heart fails to adequately pump blood to meet the body's demands. This electronic medical record database contains data on symptoms, medical history, physical attributes, and clinical test results. Let me show you. Here's the reference and some of the attributes and their description. If you're interested, email me at consulting@solver.com and I can share the slides with you. Let's go back. Here are the features or independent variables in this data set. We have age, anemia, all the way to death event. Our output variable is death event that takes 0 if a patient is still alive at a follow-up visit, and 1 shows that patient did not survive. So we have total of 13 variables detailing 299 patients with heart failure. Our goal is to utilize data science techniques to help healthcare providers reveal crucial predictive factors early and intervene accordingly to increase the survival rate of heart failure patients. Let's begin with understanding our data. You can always start with Chart Wizard. Click on Explore Chart Wizard. You can create 8 different types of charts, from simple bar and line charts to histogram to parallel coordinates and scatter plot matrix. We can try a scatter plot matrix. You can adjust the variables included. I am going to make some changes and include ejection fraction and serum creatinine and remove some of these ones. On the right side, you can color by your output variable, for example. Let's focus on serum creatinine. Normal range is between 0.7 to 1.3 for men and 1.1 for women. As you can see, in the normal range, there are less death events. As the levels rise beyond this range, the risk of death events increases. Ejection fraction measures the percentage of blood leaving a ventricle with each heartbeat, indicating heart function. A normal range is between 52 to 72% for men and 54 to 74% for women. Based on research, levels below 40% indicate a high risk of heart failure, correlating with higher death rates. Our histogram indicates the same outcome. I'm going to close this chart. Let's use Analyze Data next. Here you can generate a multivariate chart for any number of scale or continuous or categorical variables. This is useful in understanding your data while in the process of building your data science model. You can look at your data as a realization of an uncertain variable, similar to simulation modeling. Confirm the data source, including worksheet name, data range, and workbook. Next, we have to select the variables to be included in the analysis. Age. These are, let me just select creatinine phosphokinase. There are scale variables, diabetes and anemia. They are categorical. Ejection fraction is a scale variable. High blood pressure is categorical. Platelet. These two also are scale variable or continuous. Sex or gender is a categorical. Smoking is categorical, and this event is categorical. We're going to skip time for the analysis going forward. This is for illustration purposes. And the options section, you can choose to write the reports and use sampling for large data set. And you can use the fraction percent slider to limit the amount of data utilized when creating the chart previews. So let's click on finish. Immediately results appear. This multivariate chart displays a bar chart for categorical variables and histogram for continuous or scale variables. You can double click any chart and access a more detailed view of the chart and various computed information such as the statistics, percentiles, Six Sigma, and much more. The Analyze Data dialog contains 3 tabs with different distributions of variable values: frequency, cumulative frequency, and reverse cumulative frequency. Let's hover over a bar. As you can see, it populates the bin and frequency headings at the top of the chart. Red vertical lines are at 5 and 95 percentile values, displaying the 90th confidence interval. The middle percentage is the percentage of all variable values that lie within the included area. Percentile values can be altered by moving either of the red vertical lines to the left or right. Let's look to the right. The Statistic tab displays numeric values for several summary statistics, computed from all values for the specified variable. Let's close this chart. This worksheet contains all computed statistics, percentiles, and Six Sigma indices for each variable included in the report. Let's go back to our data set and find out which variables are most significant. Let's talk about dimensionality reduction. It is the process of getting a lower dimensional representation of original data that still captures the most significant relationships to be used to represent the original data in a model. It is divided into two branches, feature selection and feature extraction, both available in Analytic Solver. Feature extraction attempts to map a high-dimensional model to a lower-dimensional space. For this method, you have principal components analysis under transform. Feature selection under explore attempts to discover a subset of original variables. The main goals of feature selection are cleaning the data, eliminating redundancies, and quickly identifying the most relevant and useful information hidden within the data, hence reducing the scale or dimensionality of the data. In this data set, we're working with only 13 variables. In a more complete medical record database, the number of features for each patient can be significantly higher. So utilizing feature selection techniques enables us to efficiently identify the most predictive variables related to our target outcome. Here we want to find out which attributes have the most predictive power in predicting the survival of heart failure patients. I already clicked on feature selection, and we have to select our continuous and categorical variables. It remembers our selection from the previous practice. And output variable is this event. Let's confirm that categorical is selected for output variable type. Let's click on Next or Measures tab. Since we have continuous variables, discretized predictors is enabled. When this option is selected, Analytic Solver Data Science will transform your continuous variables into discrete categorical data to be able to calculate statistics. You can click on Advanced and check number of bins, and you can select to make the bins with equal count or equal intervals. I'm going to accept the default settings. You can select chi-square and Kramer's V on the chi-square test. Chi-square test statistic is used to assess the statistical independence of two events. The higher the chi-square statistics, the more independent the variable. Kramer's V is a variation of chi-square, the statistic that also measures the association between two discrete nominal variables. And it ranges from 0 to 1, with 0 indicating no association between two variables and 1 indicating complete association, almost like two variables are equal. Let's keep mutual information and gain ratio. We'll talk more about them. Let's click on Next. This is output option dialog. You can check to get the top features table. Let's check to get feature importance plot. And let's include all of our features. So I'm going to increment the number. And you can rank by the selected test. Let's keep the chi-square statistic. So we are going to have a graphical representation of variable importance based on the measure selected in the rank by drop-down menu, which is chi-square statistic. Let's click on Finish. Here are the results. Let's go to the next workbook. Top features. Here is the feature importance plot, ranking the variables by most important and relevant according to the selected measure. We can see that ejection fraction is number 1. Then we have serum creatinine, followed by age, serum sodium, and creatinine phosphokinase. These are the top 5 most important relevant variables according to the chi-squared statistic. After platelets, then blood pressure and anemia are less significant. As you can see, blood pressure and anemia, smoking, gender, and diabetes are less significant. Let's close this and go back to feature selection output. This is a detailed feature selection report displaying each computed metric. According to the chi-square test, sorted from largest to smallest, ejection fraction, serum creatinine, let's include it, okay, age, and serum sodium are the top most relevant variables. Now we can sort the Kramers from largest to smallest, and again we can see ejection fraction, serum creatinine, age, and serum sodium are the top most relevant variables. For mutual information, we can sort from largest to smallest, so let's do that. Again, as you can see, we have ejection fraction, serum creatinine, age, and serum sodium. This statistic measures how much information the presence or absence of a feature contributes to making the correct classification decision. So the closer the value to 1, the more contribution the feature provides. And finally, let's look at gain ratio. We are going to sort it from largest to smallest. The larger the gain ratio value, the larger the evidence for the feature to be relevant in the classification model. So let's sort this from largest to smallest. So this time, serum creatinine appears first, then ejection fraction, creatinine phosphokinase, and then age. Feature selection tool allowed us to quickly explore and learn about our data. We now have a pretty good idea of which variables are the most relevant or most important to the prediction model, how our variables relate to each other and to the output variable, and which data attributes would be worth extra time and investment in future data collection. Now that we understand our data better, how can we determine if a new patient is at risk of mortality due to heart failure? We need to feed a supervised model to our data, then score the new data using the fitted model. Let's practice this together next. Our goal is to find the best model to fit to the dataset, and then use this fitted model to determine if a new patient is at risk of perishing due to heart failure using the score option. Instead of trying, so our output variable is this event, which is categorical, so you can use classification algorithms. Instead of trying multiple algorithms, we can take advantage of the Analytic Solver's Find Best Model option. It fits a model to all selected supervised learning methods in order to observe which method provides the best fit to our data. Of course, you can test each supervised method individually. However, Analytic Solver can significantly streamline your workflow by automatically identifying the best model, potentially saving you hours of effort. Let's quickly look at the data. We are predicting the risk of mortality according to patients' demographic details, underlying diseases, and laboratory disorders. And you can see that we have gender, age, underlying diseases such as anemia, diabetes, and laboratory disorders such as number of platelets and ejection fraction and more. So select a cell within the data, go to classify, find best model. Okay, let's quickly select the variables. Age goes to continuous, anemia goes to categorical, creatinine go to this one, diabetes go to categorical, ejection fraction goes to selected, high blood pressure categorical, platelets goes to this one, serum creatinine here, serum sodium here, gender here, smoking here. This event is our output variable. And we are not going to use time in our analysis, in our model. I'm going to leave the success class and success probability cutoff at their defaults. Let's click on next. Here you can choose to partition data in the pre-processing group. Let's partition our data to training and validation, 60% training, 40% validation. This is called partition on the fly that is available in all of data science machine learning algorithms. You could also use the partition on the ribbon. To set a parameter for each selected learner, you can click the parameters button to the right. So for logistic regression, you can check on parameters and adjust the parameter. Same for decision trees and rest of algorithms. I will keep the default settings to save time. If you're interested, you can refer to Analytic Solver Data Mining User Guide for a description of each parameter. In the lower section, we have scoring. Scoring determines how well each classification method fits the data. You have access to accuracy, sensitivity, specificity, precision, or F1. For this example, I'm going to choose accuracy. Accuracy refers to the ability of the classifier to predict the class label correctly. And we are going to do it based on validation partition. Let's click on next. Let's choose to get the detailed and summary reports for training and validation data. And click on finish to get the results. Just before that, I just want to point out that you can score new data as part of the algorithm or later use the score on the ribbon. I'm going to show you the score on the ribbon. Let's click on finish to get the results. CFBM output. This worksheet contains a listing of all model inputs, such as input-output variables and parameter settings for all the learners, as well as model performance tables containing evaluation for every available metric, every learner on all available partitions. The learner identified internally as performing the best is highlighted in red. As you can see, it is logistic regression with an accuracy of 72% for validation. If you do it based on training, then you would see the selected measure based on your training data. Let's click off CFBM training score. This report contains scoring information on training partition using the best learner. Misclassified records are highlighted in red. You also have access to a confusion matrix displaying cases that were correctly and incorrectly classified. You can see that we have a 25% error. Then we have CFBM for validation data. Again, 27% error. Next is CFBM stored. This worksheet contains the PMML or predictive model markup language model, which can be utilized to score your new data. So we found that the logistic regression is the best choice. You can recognize the significance of the find best model tool in achieving accurate prediction during the early triage of patients, and how this can impact healthcare and hospital resource allocations, ultimately enhancing healthcare services. Now, let's use the fitted model to score new data. I have created data records for 4 sample patients to illustrate the scoring process. So let's go ahead and select the cell within the data, within the new data, and click on score on the ribbon. First part is data to be scored, worksheet new data, A1 to K5. Now we have to choose where is the stored model. Let's choose the workbook, healthcare clinical records, and CFBM stored. That's PMML model. Next, you can go ahead and match by name. Click match by name to match the variables listed under variables in new data with the variables listed under model variables. And then you can click on finish. Here are the results. As you can see, here is the probability of belonging to class 1 for patient number 3. indicating a high risk of mortality. Let's move on to the next topic. We are going to find out how you can combine and compare multiple algorithms in an executable workflow in Excel using Analytic Solver Data Science. For example, I will show you how to compare a single classification tree algorithm with ensemble method random trees. Let's go back to our data set. Okay, select the cell within data. This is called task pane. Data science workflows can be created in two ways, by recording or manually. For recording, you can just click on Start Recording button. I will show you how to use the manual option. Let's start by getting the data. Under Get Data, let's drag New into the workflow window. And then Data dialog will open. Under the data source, let's confirm that we are using the right data set. The heart failure, click on record, and let's click OK. Next, let's partition our data set. I'm going to use a standard partition. Let's find partitioning. Standard partition, drag it and drop it here. Let's select all the variables, move them to selected variable, going to escape time, and let's click OK. As you can see, immediately the workflow updates in the workflow window, displaying the connection between data source and standard partition. Next, let's click on Classify, Ensemble, scroll down to Random Trees. Drag it and drop it here. I have to quickly select the variables, age, anemia was categorical, creatinine, ejection fraction, high blood pressure. No, these two are continuous. Platelet here, these two here. Diabetes, high blood pressure, sex, smoking here, and this event is output variable. Let's click on Next. Let's make sure that partition data is selected under worksheet, and let's click on Next. Here we can increment the number of weak learners to 20. Here a weak learner is a single classification tree. So this will tell Analytic Solver Data Science to construct 20 different classification trees during the run, train each one on different subset of data, and combine the results to get a better classification. We can click on Show Weak Learner Models. Let's click on Next. Let's go with Summary Report and click on Finish. Again, the workflow will update immediately by connecting the standard partition icon to the ensemble classification tree icon or random tree. There is no limit to the number of workflows appearing in the workflow window. You can run several different classification regression algorithms at the same time. Now let's compare the random trees with a single classification tree algorithm. This is just for demonstration purposes. So let's go to classification tree algorithm, drag it and drop it here. Let's make sure you can see the data is not correct. So let's point to our standard partition, the partition data set. Again, we have to quickly choose the variables. Anemia, okay, anemia, diabetes, creatinine ejection. These are going here, high blood pressure going here, and this even going to output variable. Let's click on Next. This is a single classification tree. Let's go ahead and choose accept all the, you can prune the tree and choose which tree. You can use fully grown tree or best prune tree, and then we can choose a tree to display. Let's look at the fully grown tree. We also have options for prior probability. Again, let's stick with summary report and click on finish. You can click on this button to format the workflow. Let's execute the workflow. Okay, here are the results. For classification 3, I'm going to use the output navigator to quickly go to the training classification to look at the results. Here is the training classification summary. All the records were classified correctly in the training data, resulting in error of 0, and accuracy is 100%. And next, let's look at the validation. There were a total of 39 cases misclassified, resulting in a 32% error. Here are the random tree outputs. Here's the output navigator. Here are the random tree models. All the models are presented here, all the weak learners. Let's look at the classification summary and look at the validation. And the results are slightly better. The previous error was 32%. Here the error is reduced to 28%. Ensemble methods are very powerful and typically result in better performance than a single tree, than a single weak learner. Now that we have reviewed how to build a multi-stage data mining workflow in Excel using Analytic Solver, how can we easily share our model and its results with other users in a repeatable and manageable process? In this part of presentation, we will go over the advanced capabilities of Analytic Solver to enable your model to be used wherever and whenever it is needed. You can achieve this by using a cloud service by calling a Raison server. The good news is that you can deploy your data science models to the cloud to Raison entirely within Excel and even check runs of those models without leaving Excel, so no code. Let's click on Analytic Solver Deploy Model. If you aren't sure where to start or what you need, you can use Deployment Wizard to help guide you through the Create App menu options. When you click on Next, you will be guided to select the best way to deploy your Excel model or data science workflow. Okay, let's close that. Let's go back to Deploy Model. Let's click on Cloud Service Raison Model. Let's give it a name. I'm just going to accept the default and click on Save. Immediately, a browser opens. This is Raison.com. Our multi-step data science workflow is automatically translated to its equivalent expressions in our JSON modeling language and appears in a graphical form in this script, which is now called a decision flow. To see the decision flow in Raison language code, you can click on this button and request to show Raison model editor. And here is our decision flow in Raison language, in JSON code. During this time, our workflow is also posted to our Raison server. So we just use our data science workflow as a RESTful service. As you may have noticed, we are currently on Raison.com. We are looking at Raison through a front-end portal, which is at Raison.com, and in the background, there is a REST API service that can be used by any application. To make it clearer, Raison.com itself is also an application that uses the backend service at Raison.net, which exposes a REST API and allows any other application to perform optimization, simulation, solve models, fit a train model, invoke a train model to score new data, and much more. Now, to solve this model on the Editor tab, under Model Execution, let's click on Post, Solve. This submits our decision flow to the queue. Here are the results in OData format. You could also see the results in JSON syntax. The status of all calls to the Raison REST API will appear here in the output pane. If you wish to edit your model, you can do that directly in Rayzon or make the desired changes in Excel workflow and redeploy the workflow. You can make your model results available to other people using a web application and embed your data science workflow and create your own web page. Let's see how we can accomplish this. Let's go back to our code. Okay, let's click on Create App, Web Page. Immediately, we have access to this newly created web application from our data science model. As I clicked on the web page, the decision flow on Rayzon.com in Rayzon language was automatically embedded in this HTML web page. Here we are calling our Rayzon REST server at this URL. Then we have these solve buttons in the web page. They are hooked up to pieces of code. They make AJAX calls to Rayzon REST server. To view the source code used in this web application, you can right-click and click on View Page Source. A browser opens displaying the code for the web application. This is a single standalone HTML web page that uses simple JavaScript. It uses HTML to define edit fields and buttons. It uses JavaScript to run the flow by making REST API calls to the Rayzon server. Everything you need to run the entire data science decision flow on this single page. This part is the entire workflow in JSON. You can see the whole Rayzon model embedded here. These JavaScript functions make AJAX calls to our server. This is just an example of making calls to Rayzon REST API endpoints. Let's remove the query parameter and let's choose the data file. I have it under my webinars. Now let's click on solve. The template for this HTML page is shipped with the software and it sits in your examples folder. There is a file called Rayzon template. You can double click on it and it opens in a browser. You could also edit it with Notepad. By using Rayzon Create App web page, we'll learn an easy way to communicate with Rayzon REST API beyond Analytic Solver, Data Science, and Rayzon from a web application. Next, we're going to focus on synthetic data generation. It is used when there isn't enough original data or when use of the original data is restricted by law or regulation. Today, we explore how to use it to better train machine learning models. For this practice, we are going to use loan dataset. And the goal is to create a model that is going to predict if we should grant an applicant a loan or not. For this practice, we use a loan dataset with the goal to create a model that is going to predict if we could grant an applicant a loan or not. To clarify, imagine we put this model in production and we find out that the income column, for example, in the original data set had only values between $50,000 and $60,000. Later, when an applicant with the income of $12,000 applies for a loan, the model performs poorly and loan is granted even though it is going to default, because we haven't seen that case before. One traditional solution is to adjust the machine learning model by retraining it with new data that has to 12,000 in it. However, in real life, perhaps many of bad loans are issued and result in defaults and hence adverse financial consequences before the model is retrained. Qualification of such risk ahead of time has been missing in practice. There is good news for you. Our development team invented ways to automate the entire risk analysis process and made it as simple as checking one box to add such a capability. This box is called Simulate Response Prediction and is available on the fly in each machine learning algorithm and includes the synthetic data generation. So, synthetic data makes sure there are data points that cover all the possible outcomes and avoid future poor performance. How does it work? It is complicated, but to simplify it, it is something like this. We take the column, for example, income data, we feed a method-like distribution against the original data and optimize its parameters. We use the method-like family of distributions because they are very good for fitting data. Once we fit it, then we generate samples from it. However, You can do that for multiple columns at the same time, not just one. Here is the dataset that we are going to use for this example. It is originated from lendingclub.com and is publicly available on the Kaggle machine learning website. You can download it. Here are the features or independent variables in this dataset. Not fully paid is the output variable that takes 1 if the borrower defaulted and did not fully pay off the loan. We use 12 numeric or continuous features in this dataset, omitting the credit policy and purpose. Let's select the cell within the data, go to Generate Data, select all the variables except credit policy and purpose. Move them to selected variables. Let's click on Next. Here under Parameters, we have distribution fitting options. These are the fitting options which control the automated fitting of meta-log probability distributions to each feature. You can easily and quickly adjust or remove the lower and upper bounds. Let's accept the defaults. Correlation fitting will by default construct a rank-ordered correlation matrix that includes all the features. Here are sampling options and click on Finish. As you can see, we get the frequency histograms of the known cases versus the simulated or synthetically generated cases. The original data or known cases appear on the top, and the simulated or synthetically generated cases appear in the bottom row. Let's look at DTI, or the debt to income ratio. Note that the distribution of DTI or debt to income ratio is different in the simulated cases, with more frequent cases having a higher debt to income ratio. Remember, the differences in this data gives rise to the uncertainty and risk in the performance of the machine learning model. Now that you're familiar with synthetic data generation, we can go ahead and practice risk analysis together and see how it can help us. I'm going to close this. Go back to our loan data. And we are going to use a classification tree. Risk analysis changes the focus from how accurately a machine learning model will predict a single new case to how it will perform in aggregate over thousands or millions of new cases. Furthermore, it helps to find out the business consequences and assess the risk that the machine learning model will perform differently on new data versus the training and validation when put into production use. Okay, let's go ahead and practice it together. Select the cell within the data, go to Classify, Classification Tree. Okay, output variable is not fully paid, and we're going to use everything except credit policy. They're all continuous. Let's click on Next. Let's check the partition, 60% training and 40% validation. Let's check to prune the tree and use the best prune tree for scoring. Choose tree to display fully grown tree. Make sure to demonstrate it this time. Let's go ahead and go to, let's keep the summary report for scoring. Let's go to Simulation tab. So let's check to activate Simulate Response Prediction. If you're interested, you can enter a financial payoff formula. And for this, you can use Microsoft Excel's table expression syntax to calculate a financial loss of 12 times the monthly installment if the borrower defaults on the loan. So it's going to be this 12 star not fully paid, and click on Finish to get the results. Here are the results. This is the fully grown tree. You can hover over each decision node to see the rules. Here are the fully grown tree rules in the format of a table. This is the PMML model. Let's go to prediction. This is the simulation case. On the right side, on the top right corner, click on prediction simulation. Let's compare the prediction simulation with prediction training. The simulated cases versus the training dataset. Click on training partition. The light blue bar displays the frequencies of no default or 0 and default 1 on the total known cases. Here we have 5,747 cases in the training dataset, and dark blue bar displays the same frequencies for the simulated data. This shows that the classification tree model is unlikely to predict or classify any future cases as likely to default. There is a risk that the model's future predictive power is not very good at all. This is an illustration of an extreme case of poor performance. We caught this poor performance early on by performing the risk analysis. For this real-world loan dataset from Cargill, we learned that our first try using classification tree with pruning of the tree based on the validation set yields a very poor model that won't classify any future cases as likely to default. Everything is 0, right? If you are interested, you can try ensemble methods and you will see that the model does perform much better on simulated future data. The important point is that risk analysis alerted us to the possibility of unexpected model performance in production before it happened and motivated us to keep trying until we had a model that we could be confident would perform well in production use. Let's go back to our slides for a recap. Excel makes it easier to start with data science, analyze your data, fit a model, and show the proof of concept. Analytic Solver Data Science runs on Excel for Windows, Excel for Mac, and Excel for the web. You deserve to experience an unparalleled freedom beyond Excel. With Analytic Solver plus Rayzon, you can promote data science workflows to run them on Rayzon Cloud Service and make the results available to other people. We invite you to begin exploring Analytic Solver Data Science and Rayzon Decision Services. Here is my contact information along with that of our other team members. You're welcome to contact us with any questions or comments. I enjoyed presenting this webinar to you and trust that it was helpful. To learn more about other features of Analytic Solver, feel free to join us in the upcoming optimization and simulation webinars. We appreciate your time and interest and look forward to hearing from you. It is time to end this presentation. Bye for now.